Hey everyone, imagine an AI that can not only answer questions but actually take actions using real tools, calling APIs, executing code, browsing the web, and interacting with your services. In the next 15 minutes, I'll show you exactly how AI agents use tools and APIs with clear patterns, examples, and best practices you can use today. Quick roadmap. First, we'll define what an AI agent is, then break down the architecture for tool use. I'll show real examples, like calling a calculator API and orchestrating a web search, and then share best practices, safety tips, and resources. Stick around for the demo and code patterns at the end. So what's an AI agent? Think of it as an autonomous program that observes inputs, plans actions, and uses tools to achieve goals. Unlike a static model that only answers text, an agent can call external functions, APIs, local tools, or cloud services to gather data or perform tasks. Why do tools matter? Tools extend an agent's capabilities beyond its training data, letting it fetch up-to-date information, perform computations, access private systems, or trigger side effects. That expansion is what turns clever text into practical automation. Let's break down a common agent architecture for tool use. 1. Observation input layer. 2. Reasoning planner component. 3. Tool interface layer, wrappers adapters. And 4. Execution feedback loop that feeds results back into the planner. Many frameworks implement this pattern so agents can iterate until goals are met. Not all tools are the same. Common types include web search or browser tools, computation tools, calculators, code execution, knowledge APIs, internal KBs, action APIs, send emails, create tickets, and connectors to databases or CRMs. Each requires different wrappers and permission models. Technically, tools are exposed via well-defined interfaces, function signatures, input schemas, and output formats. Wrappers translate those into safe, predictable calls for the agent. That may include validation, rate limiting, retries, and sanitizing inputs to prevent injection or abuse. Let's do a simple example. A calculator tool. The planner decides the operation, calls a calculator API with structured inputs, and receives a deterministic result. This is great for tasks that need exact numeric reasoning and avoids hallucinations from the language model. A more advanced pattern is web search and browsing. The agent performs a query, inspects search results, follows links with a headless browser tool, extracts facts, and synthesizes an answer citing sources. This pipeline requires careful state management and timeout handling. Quick demo pattern. With frameworks like LangChain, you register tool functions with metadata, then give your agent an ability to call them. Example pseudocode. Register a search tool with schema, pass it to the agent as available tools, and the agent will produce a tool call step that your orchestration layer executes and returns results. This makes the agent's actions explicit and auditable. Security is critical. Agents should use least privilege credentials, have explicit user consent for side effects, and run tools in sandboxes where possible. Add monitoring, audit logs, and human-in-the-loop approvals for risky operations. Also validate and sanitize inputs and outputs to prevent data exfiltration. Some best practices. Prefer structured tool outputs over free text. Cache frequent calls to reduce cost and latency. Implement exponential backoff for retries, and keep prompts concise. Also measure latency and cost per tool call so you can optimize the agent's decision-making strategy. Agents are powerful but not perfect. Watch out for hallucinated tool calls, overuse of destructive actions, brittle parsing of free text outputs, and security exposures. Human oversight and testing across edge cases are essential before production deployment. Looking forward, we'll see tighter tool contracts, open API-first agents, real-time streaming tool responses, collaborative multi-agent tool orchestration, and better developer tooling for testing and simulation. These trends will make agent-based automation more robust and mainstream. If you want starter code, check the video description for links to sample repos, LangChain examples, and a safety checklist. Try building a small agent today. Start with a non-destructive tool like a calculator or search tool, then iterate. Subscribe and hit the bell. I post weekly developer walkthroughs. Thanks for watching. If this helped you, like the video and leave a comment with what agent you plan to build. I read every comment and will answer questions about implementing tools and APIs with agents. See you in the next video.